Okay, here are the practice test solutions for yourself to take a look through. So number one, evaluate the expression using the formula. So this would be 8 factorial over 2 factorial times 8 minus 2 factorial, which is just 8 times 7 times 6 factorial over 2 factorial times 6 factorial. Of course, those cancel out. So it's just 8 times 7 divided by 2, which is really just 4 times 7, because that becomes 4, which is just 28. So there's your answer for that one. Okay, part 2, permutation. So 8 factorial over 8 minus 3 factorial, which is 8 times 7 times 6 times 5 factorial over 5 factorial. That goes away, so I have 8 times 7 times 6 is 336. Okay, find the sum, right? So you got first term, second term, third term, fourth term, fifth term, and sixth term. And the E, the summation notation, means we need to add them up. So this is when K is 1, K is 2, K is 3, K is 4, K is 5, and K is 6. So that's negative 2 times 1 plus 8, negative 2 times 2 plus 8, negative 2 times 3 plus 8, and all the way down the line here. So negative 2 times 4 plus 8, negative 2 times 5 plus 8, negative 2 times 6 plus 8. Turns out that this is equal to 6, this is equal to 4, this is equal to 2, this is equal to 0, this is equal to negative 2, and this is equal to negative 4. So all of these cancel out. That cancels out. 0 is anything, so the answer you're left with is just 6 for a grand total. Alright, there's number 3. Okay, number 4, find the indicated term of the sequence. Okay, brute force. I didn't spell it right. That's all right. So the first term is 3. The ratio is 4 because you got to add 4 to each one of these to get up there. So a sub n is equal to a sub 1 plus n minus 1 times d. I want to see this part. Okay, tell me you know what that part is. Then a sub n is equal to the first term, which is 3, plus n minus 1 times the ratio of 4. So then, right, I'm looking for the a sub 139th term is 3 plus 138 times 4, which is 3 plus like 500 and something, 552. So the answer is 555 with that one. Okay, find the sum for an infinite geometric series. So that means that we're going to take the first term divided by 1 minus the ratio. So please give me this. Tells me you know what the formula is. The first term, if I plug in a 1 for this, 1 minus 1 is 0. A half to the 0 is 1. So the first term has to be a 4. So divided by 1 minus the ratio, which happens to be a half here. So that's 4 over a half, which is a value of 8. All right, cool. Now we come to my favorite one, the induction problem here. So step 1, show that this is true for n equals 1. So 3 times 2 to the 1 minus 1 is the same thing as 3 times 2 to the 1 minus 1. So 3 is definitely equal to 3. Check. Number 2, you assume that it's true for some n equal to k down the line. So we have 3 plus 6 plus 12 plus blah, 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 plus 3 times 2 to the n minus 1 is equal to, oh yikes, k, excuse me, let me get that going for you. K minus 1 is equal to 3 times 2 to the k and then minus 1. So that's the second step. Third step, prove true for n equals k plus 1, the next term in the sequence. So here's what we have. We have 3 plus 6 plus 12 plus yada 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 plus 3 times 2 to the k minus 1. And then I always box this stuff because I know what it's equal to. Now I need to add on the next term. The next term would be 3 times 2 to the k plus 1 minus 1 is just 3 times 2 to the k. Then on the other side of my equation, I replace k, or replace n with a k plus 1. So that's going to be 3 times 2 to the k plus 1 in the exponent, and then minus 1 down below. Okay, so all of this stuff that's in my box is equal to the right-hand side of step number 2, which is why we write it down. So that gives me 3 times 2 to the k minus 1 plus 3 times 2 to the k. On the other side equals, I'm going to leave this alone and not touch it. I don't want to touch the right-hand side. So distributing, I get 3 times 2 to the k minus 3 plus 3 times 2 to the k. Now these two terms right here, this term and this term, are like terms. So that's 6 times 2 to the k and then a minus 3. Then I'm going to factor a 3 out of the whole piece here. That's going to give me this. 2 times 2 to the k minus 1. Now, of course, this is 2 to an exponent of 1, so that's 3 times 2 to the 1 plus k, and then minus 1, which is exactly what it says on the right-hand side there. So therefore, this is true for all positive integers n. All right, that's a good problem there. Okay, number 7, expand using the binomial theorem here. So lots of work to be done for the setup phase, right? Notice that I have a 4th degree, so that means I'm going to have 5 total terms. So the first term, second term, third term, fourth term, and then finally the 5th term. I'm going to start with all of my chooses. So 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and finally 4 choose 4. Then I'm going to take a look at my first term, which I'll do in blue for you. So 3x. So that's going to be 3x to the 4th, and then a 3x to the 3rd, and then 3x squared, and then 3x to the 1st, and then 3x to the 0. Then in green here, I will do the 4th term. So that's going to be 4 to the 0, 4 to the 1st, 4 squared, 4 to the 3rd, and finally 4 to the 4th. So I want to see all of this, right? This is the setup phase. The first term is positive, negative, and positive. Remember, signs alternate if there's a minus sign in between them. So all of this stuff here, that's the setup phase. So I want to see all the setup on your work tomorrow, okay? Then we need to clean all of this up. So 4 choose 0 is is 1. So I'm going to have 3x all to the 4th. So that becomes 81x to the 4th. Minus 4 times 27x to the 3rd times 4 plus 6 times 9x squared times 16 minus 4 times 3x times 64, and then finally plus 256. So that's one phase of the cleanup. Then I need to clean up all the rest of my terms. So like this term I have to multiply out, and multiply out. So my final answer looks something like this. 81x to the 4th minus 432x to the 3rd plus 864x squared minus 768x plus 256. Big problem, easy to break down if you show me all of these phases, which is I call the cleanup phase. Okay, so show me the setup, show me the cleanup, and you guys got it. Okay, number 8. Using the digits 0 to 9, how many 7-digit numbers can be formed? Repeats are not allowed. That's a clue that this is a permutation problem. So I have 0 to 9, so I have a total of 10 digits, and I'm going to permute 7 of them. So that's just 10 factorial over 10 minus 7 factorial, which when you plug into the calculator becomes 604,800. So I want to see all of this. This is considered showing me the work. Okay. Number 9, a license plate consists of one letter followed by 4 digits. 1, 2, 3, 4. The letter cannot be a 0 or an I. That leaves me with 24 choices for my letters, right? Because there's 26 in the alphabet, but it can't be a 0 or an I. Then I have my digits over here, and it cannot be a 0 in the lead position. So this leaves me with only 9 choices. But everything else, I have 10 choices that I can use from, right? Because there's 10 digits. All of this is the multiplication principle. So we multiply it all together. So that's 24 times 9 times 10 to the 3rd, which happens to be 216,000. So all of this is what I want to see on the work. All of that shows me you know how to set it up and then get the answer. So that shows your process. So please put all that on the page. Okay, number 10, the committees one. Forming a committee, you've got 5 guys trying out, 8 women are trying out. but only 2 from each can be on there. So we have to do a few things. We have to pick the men, and then we have to pick the women. Okay, so how many ways can we pick 2 men from 5? Well, that's just a 5, choose 2. How many ways can we pick 2 women from 8? Well, that's just from the 8 women, we're going to choose 2. We're going to multiply those together. So that leaves me with 10 times 28, which gives me 280 ways. So again, this is what I expect to see on the test. Okay, not just the answer of 280. Okay, number 11, a golf ball selected at random. We got 9 white ones, we got 8 green ones, and we got 3 orange ones. Find the probability of a white. So the probability of white is going to be the number of white total, which is 9, out of all of them total. So 9 and 8 and 3 equals 20. So the probability of white is 9/20. Probability of white or green, we know that or means add. So the probability of white is 9 out of 20. And the probability of green is equal to, how many? 8 out of 20. So therefore, or means we're going to add these all up together. So 9 out of 20 plus 8 out of 20 is a grand total of 17 out of 20. So please put this and this on the page, and this. This tells me that you know how to find a probability problem. Okay, and then lastly, number 12. A spinner has 4 selections of equal area. So a little diagram here. It looks like this, and they're numbered 1 through 4. So 1, 2, 3, and 4. You're going to spin the spinner 2 times, construct a probability model. So we need a sample space for this. So the sample space is going to be consistent of I spin the spinner 1 time, and then I spin the spinner a 2nd time. I have 4 choices for the first time, and again I have 4 choices for the 2nd time. So I should end up with 16 total outcomes. So what are those outcomes? They're going to look like this. I could get a 1 and a 1. I can get a 1 and a 2. I can get a 1 and a 3. I can get a 1 and a 4. I can get a 2, 1. I can get a 2, 2. I can get a 2, 3, 2, 4. I can get 3, 1. I can get 3, 2. I can get 3, 3. Or I can get 3, 4. And lastly, I can get 4, 4. 4. I'll go backwards. 3. 4, 2, and then finally 4, 1. I changed it up on the last one just to keep you guys awake. So there we go. There's a grand total of 16 outcomes, and each probability of each, okay, is equal to 1/16. So there's my probability model, okay? I have a sample space, and I have a probability of each assigned at 1/16. Okay, also note, please be sure you study the Google problem. And that is the, like, how many different ways, different distinguishable ways can you rearrange the letters of Google. All right, that's it. Good luck.